objective of this experiment is to determine the volume and density of ball bearing and to determine the volume and density of glass block. The vernier caliper is used for measuring external thickness, internal diameters, and depths of holes to a maximum of 30.30 mm with an approximate of 0.05 mm. This measurement mostly used in the laboratory, and for this experiment, it was used for measuring a block glass. The object was placed between jaws and the measurement must be taken several times to achieve the true reading from the object used. The micrometer screw gauge is used to measure even smaller dimension than the vernier caliper. Object that was used is a ball bearing that was placed between the spindle and the anvil of the micrometer. 3 clicks of the ratchet was used before taking the readings. While measuring, a log was used to ensure that the thimble does not rotate. At the last of the experiment, the volume, density, and uncertainties of both ball bearing and glass block had been calculated.
In this experiment, we will be using micrometer screw gauge and ball bearing. First, the zero error was determined. Next, the diameter of the ball bearing was measured. Step 2 was repeated at least 3 times at different positions of the ball bearing. All data was recorded in a suitable table. The actual diameter reading was calculated by considering the zero error obtained earlier. The weight of ball bearing was determined. And lastly, the density of ball bearing was calculated. Next is procedure B. In this experiment, we will be using vernier caliper and glass block. First, the size of the object to the nearest whole millimeter was determined by counting the whole number of small divisions on the fixed part of the caliper to the left of the zero mark on the vernier. Next, how many fractions of a millimeter are needed to complete the estimate of the size of the object was indicated by the first mark on the vernier that lines up with one of the marks on the fixed part of the caliper. The zero error of the vernier caliper was determined. The length, width, and thickness of the glass are measured using the vernier caliper. Step 4 is repeated at least 3 times at different positions of the glass block. All data was recorded in a suitable table. The actual measurement was calculated by considering the zero error obtained earlier. The weight of the glass block was determined. And lastly, the density of the glass block was determined.
So this is the result of the experiment that we did. The micrometer screw gauge was used to measure the diameter of the ball bearing. To get the observed reading, we measure the diameter of the ball bearing 3 times and find the average of the diameter. To get the radius, we divide the diameter by 2. The true reading of the ball bearing was calculated by subtracting the observed reading with the zero error. Next, a vernier caliper was used to get the length, width, and height of the glass block. This is the result of the experiment. There is no zero error of the vernier caliper. Therefore, the result of the experiment remained the same for both observed reading and the true reading. This is our analysis of the experiment, which is to determine the volume and the uncertainties of the ball bearing and the glass block. To calculate the volume of the ball bearing, we use the formula of V equal to 4 over 3 pi r cubed. The volume of the ball bearing we got is 3.591 exponent -6 meter cube. And then we can calculate the uncertainties of the ball bearing and get the volume of the ball bearing, which is 3.591 plus minus 0.01 exponent minus 6 meter cube. Next, to find the volume and the uncertainties of glass block, we use the formula of V equal to length times weight times height, and the answer that we got is 1.135 exponent negative 4 meter cube. And we can calculate the uncertainties of the glass block to get the volume of the glass block, which is V equal to 1.135 plus minus 0.045 exponent negative 4 meter cube. To calculate the density and the uncertainties of the ball bearing, we use the formula of density equal to mass over volume, which we get 7.742 exponent minus 3 kg per meter cube. To get the uncertainty of ball bearing, we use the uncertainty density over density equal to uncertainty of mass over mass plus with uncertainty volume over volume, which we get 24.31 kg per meter cube. And then we get 7.742 plus minus 0.02 exponent 3 kg per meter cube. To calculate the density and the uncertainties of the glass block, we use the formula of density equal to mass over volume, which we get 239.65 exponent negative 3 kg per meter cube. To get the uncertainties of the glass block, we use the formula of uncertainty density over density equal to uncertainty of mass over mass plus with uncertainty volume over volume, which we get 5.45 exponent negative 3. And then we get 239.65 plus minus 5.45 exponent negative 3 kg per meter cube.
In this experiment, vernier caliper and micrometer screw gauge was used to measure the diameter of a ball bearing and to measure the length, width, and also height of a glass block. Vernier caliper is a measuring device that is used for the measurement of linear dimension. It is also used for the measurement of diameters of round objects with the help of the measuring jaws attached at the top of the vernier caliper. The micrometer screw gauge is used to measure even smaller dimension than the vernier calipers. Micrometer has a sensitivity of 0.01, however vernier calipers has a sensitivity of 0.02. To determine the diameter of the ball bearing, the micrometer was used as it is more sensitive in measuring smaller objects. 3 attempts had been taken in measuring the diameter of the ball bearing. To determine the length, width, and height of the glass block given, a vernier caliper was used. The volume of the glass block after the true reading had been obtained. Before experimenting, the mass of both glass block and ball bearing had been taken. With the mass obtained, the density can be calculated using the formula P equals to mass over volume. This experiment was carefully handled to obtain the perfect mass, diameter, length, width, and height of the object given to avoid any error to happen. But any error can happen without being noticed, as for example, additional mass had been added while weighing the objects because the presence of the air in the room. To avoid that to happen in the next experiment, all weighing must be done in a room where no air flows can occur. Conclusion from this experiment, the density and volume of both ball bearing and glass block had been determined. We learned about how to use the vernier caliper and the micrometer screw gauge correctly. We could get the actual diameters and external thickness from both objects, as the measurement used can measure small objects, real measurement. With repeating the measuring steps 3 times, the average reading was used.